Our next chapter will be chapter 34. We are entering the section now of where we're going to have 3 chapters on light and optics. The introduction to this was, of course, electromagnetic theory, and then the culmination of that in electromagnetic equations of Maxwell, the 4 Maxwell's equations, and the Lorentz force equation that we've just finished discussing. These lead, of course, to the proof by Maxwell that light and other electromagnetic radiation are vacuum solutions of the Maxwell's equations, which we have also just derived. So we're going to begin now looking at specific types of visible light electromagnetic radiation, which is in the domain of what we call optics. The first chapter of our 3 chapters on light and optics is chapter 34, and we're going to here discuss the concept of plane mirrors. This is chapter 30, section 34.1 in chapter 34. The law of reflection is that when light comes in at some angle relative to a reflecting surface, the light that comes in is reflected back at an angle of reflection, theta reflection, that's equal to the angle of incidence, so that theta incidence is equal to theta reflection. We always make these angles for optics relative to a normal to a surface rather than a tangent to the surface, because often we'll have curved surfaces, and the same will hold true if we have not just a flat mirror like this one, where the light comes in and then the light goes back out again, but a surface that's very convoluted, where the light might come in at a point like this, and we draw a normal to the surface, and therefore we would say the light comes in at this angle, here's the normal, this would be theta of that's incident, and the theta reflection, theta reflected, would go out so that this angle and this angle are equal relative to the perpendicular to the surface at that point. And so basically the first law of reflection is that the angle of reflection is equal to the angle of incidence. Now for flat mirrors, the left and right-handedness is reversed, as we're all familiar with. Anyone that is that's taken a mirror and looked in that mirror at some writing notices that the writing is reversed in the left and right-handedness, but is not reversed in the up and down aspect. One way which we see this very frequently is if we look in our rearview mirror, we see the word ambulance written normally in our rearview mirror. But if we look at the front of an ambulance, the ambulance is written as a mirror reflection so that a car can understand it and see it and read it in their rearview mirror. Now, if we have a mirror, let's say this is a mirror, and we have an object back here. There's a little person. And as the light from this person goes into the mirror and comes back to, say, our eye, and here's our eye looking at this person over here, then we will see that person the same distance behind the mirror as they are in front of the mirror on this side. So the image of this person is right back here and is the same distance. So if this is a distance d of the object, then the image, d of the image, will be the same. So the distance of the object and the distance of the image are the same. So we perceive this person to be behind the mirror at exactly the same distance as they are in front of the mirror. And so the reflected object is on the other side, the same distance. It's not reversed for vertical, but it is reversed for left and right. We have that left and right inversion. And so this kind of covers the basic concept of reflection in a mirror that's plane and flat.